Okay, let's get started. はい、始まりました。
We are broadcasting now.
Well, so
Hi.
should we stop talking?
No, no.
No. So you don't need,
Please chat.
yeah, you don't need to be on mute. You can still.
Okay.
はい、ライブストリーミング始まってますが、8時まではおしゃべりタイムになってますので、皆様準備してお待ちください。
So you are in Amsterdam, right? Did you
Yes,
say
I am.
so?
Yes.
So is
yes.
how is the situation of COVID right now? Is it
It's,
getting better?
It's I'm not sure. It's about the same, I think. I don't think it's getting better. There are still many people in hospital, about the same as this time last year. The schools are closed. The shops are closed. Cinema is closed. Everything is closed.
Wow.
You can order takeaway food from restaurants. There are some shops, a few that are open. You're not allowed to meet with more than 2 or 3 people in a house. There's many rules, and it's very strict, very strict.
So
And how is
Yes.
it there?
yeah, that's a bit different from Japan. In Japan, now everything is open, right? In Tokyo as well, right? Everything is open, but the situation is getting worse.
Really?
Yeah,
Getting worse, better, better.
yeah. Now it's
It's
not good currently.
especially the west part of the Japan has more, not you know.
Increase the victims.
Increase.
I don't know how to say.
Yeah.
なんだっけ
victims.
じゃなくてなんだっけ
Yeah.
患者
There are more sick people.
Yeah.
Yeah,
Sick people.
patients. I'm sorry.
Patients. Yeah.
Yeah.
Patients.
Are increasing.
Or more zombies.
Yeah,
Zombie.
yeah.
Yeah. It's very strange. I mean, this pandemic is all over the world. Everyone has the same situation.
Yeah.
Yeah.
This is.
But sometimes it seems to be getting better, and then the next week it's worse. And it's very difficult to know what the situation really is.
Exactly. I don't know what is happening. Actually.
I don't think anybody knows. But now the weather in Europe, it's now becoming spring, so it's warmer weather. So maybe that's good to kill this virus.
Yeah, right. I hope so.
How is the weather there?
Tokyo is sunny.
It's getting warm
Yeah.
too.
So in Amsterdam, start vaccine?
Yes.
Yeah.
But it started just for people who are quite old. So my wife's mother is 85, and she has had 2 vaccinations. But for my age group, there hasn't been vaccination yet, and it's only been for people who are really old so far.
Same situation maybe in Japan.
Yeah.
Yeah, same here. Yeah.
Really?
Yeah.
Okay.
So
Yeah.
it's time to start. But firstly, I will explain you and but there's no Mr. Simon yet, but yeah, I'll start in Japanese and then let's start the session. それでは、2021年4月の JJUG ナイトセミナーを始めたいと思います。今もうセッションを聞いてる人が YouTube にいるはずですよね。はい、今50人ほど。はい。いらしてくださってありがとうございます。で、今日はFoojay という Java の、SNS というかコミュニティというかの、企画として Foojay バーチャル JUG ツアーっていうのを今行っていまして、その一つとして日本の JJUG でセッションをしてもらいます。で、まず前半は、Geertjanさんからちょっと日本人には発音が難しいGeertjanさんからFoojay の全体的な説明を10分ほどしていただいて、でその後サイモン・メイプルさん、今いらっしゃいましたね。サイモン・メイプルさんにセキュリティとかVulnerabilityの、説明をしてもらおうと思います。Okay, so Geertjan Simon-san, thank you for joining JJUG Night Seminar tonight. So let's please start the session.
Perfect. Thank you very much. So hello everybody. My name is Geertjan. I am in Amsterdam, and what we are doing today in the Japan JUG is to introduce you to a new website called Foojay. And to promote the website, we are going to many different Java user groups online. So we're going to many different virtual JUG events. We've been to about 10 in March, and we're doing something like 15 in April. And at each JUG, so you can see that we are now down here in this slot. So almost finished the tour. And at each JUG, we are very shortly introducing what Foojay is, and then somebody from the Foojay community is doing a session. So that's why Simon is here from Sneak to talk about a topic that relates to Java and security, because that is what Sneak is really an expert Java organization in. So I will introduce Foojay in about 10 minutes, and then Simon will do his talk. And so to tell you briefly about what Foojay is a community site for everyone who is using Java in some way. So if you are writing applications in Java, if you're doing anything with Java, you want to know what's going on in Java, you want to share information with other people, then Foojay is a site that is very useful to you. Foojay stands for Friends of OpenJDK. So the F from Foojay is from friends, and O from the first O is of, and then the second O is open, and J is for Java, for the JDK. And here's our logo. It's a bird. It's a J. It's a kind of bird. And Foo is often used in Java programs, in demonstration programs. When you're creating a demo, you will use terms like foo and bar. So foo is kind of a placeholder. So if you have any content that you want to share with other people, or if you want to share tips and tricks, then we can give you a user and a password to the Foojay site. The Foojay is simply a WordPress site. So if you know WordPress, you can work very easily with Foojay, and then you can put your content into the WordPress, and then every Monday on the Slack channel. So there's of course a Slack channel that you are very welcome to join. And every Monday we discuss the content for that week. And every week we want to post 5 new articles every week. So Monday, Tuesday, Wednesday, Thursday, Friday, we have a new article, and you can see that here. So there's a part called Foojay Today, which is the blog area. And every day there's a new blog on something related to Java. And so if you have content about Java, if you have tips and tricks, if you have articles, if you have tutorials, it would be great to publish them or republish them on Foojay. But in addition to this, what Foojay is also for is to give you information about the current state of Java. So every quarter, there is a new release of Java. So there was a new release that came out yesterday, the April 2021 release. And in that update for Java 8, there were 227 fixes. And if you look for Java 11, so in the latest quarterly update, you can see that there were also that same kind of number. And when you look in Java 16, so here is the list of fixes for the latest update for Java 16. So this is what's new in Java. And there's really nowhere else online where you can find information like this, a long list of all the fixes that have gone into a particular update. And you can look through these issues. These have all been fixed. So if you're using Java 16, you should upgrade to Java 16.01. If you're using Java 11, you can now upgrade to Java 11.011. So that's the latest Java 11 update. If you're using Java 8, you can now upgrade to Java 8 update 292. So this is the latest update for Java. And here are all the new fixes, the new enhancements in that release of Java 8. So you can look through these and you can vote on them. So if you click on the star on the right-hand side, those items will be shown in the highlights page. So the highlights page shows all the items, all the fixes that people have voted on. So here you can get a view onto what the community likes in the latest quarterly update. So this is a very important part of Foojay. It gives you information about what is new in Java. Now, secondly, something else that can be very confusing about Java is there are many different open JDK distributions. When I was working in Sun Microsystems a long time ago, there was one Java. Java was created by Sun. But now there is the open JDK distribution made available by Amazon called Corretto. And there is the Adopt OpenJDK distribution. And Alibaba has an OpenJDK distribution. And Azure has an OpenJDK distribution. And Red Hat has an OpenJDK distribution. So here you can get here you have a list. And actually, Microsoft now also has an OpenJDK distribution. So we need to add Microsoft in here. So here is a list of all the different OpenJDK distributions and where to get them from. So if you click on these links, you will go to the download page for that particular OpenJDK distribution. So Foojay gives you information about what is new in Java, but also tells you where you can go to get Java, because Oracle isn't the only provider of Java anymore. There are many other organizations that are also providing Java. So there are, this gives you a starting point for getting to those different distributions and also to see what the differences are between them. Now, something else is, if you're using Java, you often use command line arguments. Now, does anyone know where to go to find all the command line arguments? So on Foojay, you have that information. So you can see, here we are in Java 11. Here are all the, you can see there's 1,989 JVM command line arguments in Java 11. And there were 53 that are new in Java 11, and there's 27 that have been removed. And as you move to a different version of Java, you see what command line arguments are available. So Foojay is really an information site that brings together content from Chris Newland. So he's a Java champion. He has a website, Chris Who Codes, where he has this information, which is integrated into Foojay. It brings together content by Mark Hoffman, who's also a Java champion, who has Java Almanac. And it brings together this content about what is fixed in the OpenJDK for the most recent releases. So that's the focus of Foojay, to provide you with a place where you can blog. So you can come and provide your content here. There's an opinion poll. There's an events calendar. So if you're organizing a conference, you can promote your conference on Foojay. Or if you have JUG events, you can promote those JUG events on Foojay. So it's really a place for friends of OpenJDK. So also, if you say nice things on Twitter about Foojay, then we put your tweet in the greatest tweets. And you can see there's also the latest tweet. So it's a place for friends of OpenJDK. So if you are somehow using Java, then you are a friend of OpenJDK and you can join in with the community to collaborate around Foojay. Now, who are the people behind Foojay? Who has put this together? So Foojay has a board. This is the board of Foojay. And Azul has taken the initiative to set this up, but Datadog is involved, DataStax, Hazelcast, JFrog, Payara, and Sneak. So these are all very well-known Java technology organizations, and more will be joining over time. And you can see some very nice things here. So for example, Stephen Chin, that many people might know, a nice statement from him here is, Foojay is an example of the strength of the Java community that is greater than any single company. So it's about bringing together as many people and as many companies as possible to collect all the information around Java in one single place. And also Simon, who's speaking in a minute, he said something really, really great about Foojay here, I think. He says, it's incredibly important for every ecosystem to have a core location for information to help grow the community and to be an educational resource for all developers to use. And Java has lacked this core space for many years. So Java hasn't had such a thing like this. And so, yeah, you are warmly invited to join in. There is the Slack channel that you are invited to join, and I'll put the link to the Slack channel in the chat in a minute. But what is also really important is there is a Twitter handle. So Foojay.io is the Twitter handle. And if you follow Foojay, so recently we crossed the 1,000 followers mark in 1 year, which is pretty good. If you follow Foojay.io, you will get a tweet every day with an article or a tip or a trick or something related to Java. So if you are a Java developer of some kind, it would be very useful for you, I think, to follow Foojay, and it would really help to build this community around Foojay. So you can see more and more people are joining and following Foojay. And so it would be great if you would follow Foojay. We really need to get the number up as high as possible and get lots of people active on Slack and on providing content and so on, to really bring together the community and to have a place for friends of OpenJDK. That is my introduction to Foojay. Thank you very much. And maybe we can switch back to the moderators or to Simon for his talk.
Yeah, thank you for your talk. I have we have one question, and so
yes.
Which is your recommendation OpenJDK distribution?
Well, I mean, they're actually all the same. That's the nice thing.
I see.
All these OpenJDK distributions, they're all different distributions from the same source. Personally, I work for Azul. So Azul makes available Zing and Zulu. Zulu is an OpenJDK distribution. I think one thing you do need to think about when you look at the OpenJDK distributions, an important question is it TCK licensed? I think that's a very important question because that's the common standard for testing the OpenJDK. So I think that's one important question. A second important question is there support for the OpenJDK that you are using? So if you have a problem, do you have somewhere to go to for solutions? I think those are two important questions, but in general, they're all the same. All these OpenJDK distributions are the same, really.
I see. Thank you. So I translate it in Japanese. 質問、YouTube の方で質問をいただいた、おすすめ好きな OpenJDK ディストリビューションがありますかという質問について、聞いてみたところ、基本的には全て同じだろうと。で、大事なのは TCK を取ってるかどうかと、 サポートがあるかどうか。例えば、問題が起きたときに問い合わせられるところがあるか。その2つの観点で見ていて、ゲラちゃんさん自体は、Azure の OpenJDK を使っているそうですが、基本的には大きな差は、同じソースコードから作られているので、大きな差はないよねというお話でした。Okay, so thank you for your session. So
Thank you.
Thank you. And let's go to the next session. So Mr. Simon, please go ahead. Please start your session.
Thank you very much, and also thank you very much for inviting me. It's a big privilege. I think this is my first session that I'm giving to a Japanese community, so it's a big privilege to be here. And thank you for your invitation. Yeah, I'm going to be talking about security, and in particular how we as developers can write more secure code and deliver more secure applications. I will provide a number of slides, but most of this session will be around hacking and working out how we can defend against that as well. So I'm going to go ahead and share my slides on this screen. Let me do that now. There we go. Okay, and hopefully you can see that nicely. If there's any questions, please do interrupt as we go, and I'm happy to take those questions as we go. Okay, right. So my name's Simon Maple. I'm the field CTO at Sneak. I've been at Sneak for 3 years now, just over 3 years. And Sneak is a developer-first company that looks at helping developers fix issues in their code and their application. My background, many of you may have heard of the virtual Java user group, an online user group, which is, 8 years old now. And this is something I founded and have led for a number of years. I don't have as much time to put into that community as I would want to, but it's still a very vibrant community. I'm also one of the co-leaders of the London Java user group here in the UK. I've been a Java champion for 5-6 years, maybe, and some other awards there on that screen. So before we jump into some hacking, I want to talk a little bit about how applications have changed pre-cloud and how they've changed because of cloud native technologies. Before we used cloud heavily, applications from a developer point of view tended to be more focused around open source libraries and application code. So this is the code that we write in our IDE, and the libraries and frameworks that we use as our dependencies to our application. From a development point of view, we didn't really worry too much about what the application was deployed on. That this was more of a concern for an IT department, an ops team, and we very often talk about a wall between development and ops that we used to throw code and applications over for it to be deployed. And the IT team looked after hardware, virtualization, VMs, any applications that were supporting, and so forth. Today, our applications look very different. In the cloud native era, we don't just look after our code and our libraries. We also think about how we deploy that. So after DevOps arrived, we have to think about more of the, if we write it, we run it, we deploy it, we maintain it kind of attitude. And this means thinking about the containers we deploy in, any of the services we deploy with, perhaps databases and things like that, Kubernetes orchestration tools, these kind of things. And as a result, there are many, many more vulnerabilities, attack vectors, misconfigurations that we as developers need to think about, because when we start creating this kind of code, we need to be responsible for the maintenance and the security of that. So when we look at our application and how our application has changed, previously we really cared about the custom code and the open source code that we want to secure. However, now we have containers. We have in those containers Linux packages potentially with a large number of known vulnerabilities. Maybe we deploy with infrastructure as code. If we do that, how many misconfigurations could there be in our Kubernetes config, in our Terraform scripts? We need to think as we write these different artifacts and as we use these different technologies, what are the potential security risks and threat points for each of these? So when we think about, pardon me, when we think about your application, in terms of just the code that you write and the code that we pull in as third-party libraries, it likely doesn't surprise you that there are a large number of libraries that make the majority of your application. So the code that you write in your IDE is relatively small in comparison to the application that you deploy. So here is in fact, in this case, we have a JavaScript example where we have 19 lines of JavaScript code. And in these 19 lines of code, we have 2 direct dependencies. So dependencies that we explicitly mark as libraries or frameworks that we depend on in our code. Obviously in Java, this would be done through a POM XML or a Gradle build file. Now, have a little think, feel free to use the chat if you want, but have a little think about how many dependencies you think this application will depend on in total. Because when we think about the direct dependencies, that's not the end of the dependencies that we rely on. There's obviously a dependency graph, and that will include transitive or indirect dependencies that can go many levels deep. So have a think about how many dependencies you might have in your entire application. In this case, the answer is 19. So we have 19 lines of code, 2 direct dependencies, and 19 total dependencies. So actually, 1 line of code now means 1 dependency. So our small application that we thought was nice and small may actually be bigger than it is. Now, if I was to ask the question, how many lines of code do you think exists in this entire application? That includes the code I've written here in my IDE, as well as the code that exists in the 19 dependencies. I wonder what you might think. Maybe you'll think 5,000, 10,000, 50,000. Well, in this case, the actual answer is almost 200,000 lines of code. So 2 things to mention here. One is not all of those 200,000 lines of code will actually be used in our production environment. There will be an amount of code in libraries that just exist, and we're not using the library in a specific enough way to go through that code. That's possible. But the key thing to take away is when we think about our application, think about the application that we use in total, not just what you see in your IDE. The big breach that occurred a few years ago in the US mostly was Equifax. And Equifax were using Apache struts under the covers in their application, and it exposed the actual breach exposed over 140 million US consumer data, sensitive data entries. Under the covers, this is Apache struts, and you'll notice when exploit code becomes available on the exploits database or just in GitHub as an example demo of how to hack a package or a vulnerability, the number of attacks that occur as a result jumps very, very quickly because it's very easy to attack endpoints when you know what the actual attack needs to be. It's very easy to run scripts, to run code that performs an attack. The hard piece is actually to create that exploit straight away. Let me show you the actual vulnerability in this case, and then we can go from there. So I'm going to jump to this application. This is a Spring and struts application. So I'm just going to add my details in here. 1, 2, 3, 4, 5, 6. There we go. That seems secure. Chrome will tell me 1, 2, 3, 4, 5, 6 isn't a good password, but I don't believe it. There we go. This is my to-do application. I can create to-dos, etc. It seems all very nice application. In my about box, you can see I'm using struts, Spring, Hibernate. You won't normally get information this easily, but it's not hard to find some information about applications, particularly when you see things like stack traces or information in your HTTP responses, these kind of things. So we're going to attack this struts endpoint, which is an application running on Heroku, on a Heroku cloud. So I'm going to go ahead and this is the one I want. I'm going to go ahead and show you what the header file looks like that I need to send to this endpoint to attack it. This is the header or part of the header that I'm going to send. And you'll see that we send a content type. The content type starts with a % brace and ends with a brace as well. This is an illegal content type. And so we will go down an exception path in the struts code. Now, when we go down that exception path, we will use a library called OGNL. And OGNL is a library that does many things. In this case, struts would be using it to create a nicer exception message for users to be able to understand, or admins to be able to understand what went wrong. However, OGNL also evaluates strings or text that start with a % and are surrounded with this brace. So this text, which the Apache Struts library is trying to format and use to provide information back to the user, is going to be evaluated by OGNL. And while that is run and evaluated, our Java Lang process builder is going to be created. And when we create this process builder, we run a command here. As you can see, if I was to make that a touch bigger, you can see we execute bash, passing in a command. And the command we run is here just a placeholder. So I can change this when I actually perform the attack. So my next thing I'm going to do is copy this and grab this exploit string. So what we're doing here is we're passing this headers file that I showed you just now. We're going to do a string substitution. We are substituting command, the placeholder command, with env. And env is something that we will execute on the remote Heroku machine, and it will provide us back the environment variables on that machine. We're going to curl this to an endpoint. I will replace this endpoint rather than localhost. I will replace this with my Heroku endpoint there. So we will attack just the home page. This is the home page of our application. And I execute this, and there we have the environment variables of that Heroku machine. So when at this stage, think about it from an attacker point of view. At this stage, I, as an attacker, maybe will learn more about the system through passwords, API keys, configurations, ports, paths, a lot of information I can learn just from this. However, having this information now, I have executable rights on this machine. So maybe I can start running other things. Maybe I can look at what processes are running. Maybe I can try and install or execute malware on this machine. It all depends on the process, the permissions that I have on that process. In this case, I'm running as a root, and I'm running as a root on that Heroku machine because the Tomcat server that this struts application is running on is being run by the root process. Okay. So this is a good example. It's not just struts. There are other ways in which this kind of application, this kind of remote code application can be done in some maybe more popular environments as well. For example, in Spring, what I'm running in my next example here is a Spring application. It uses Spring. It's a Spring Boot application. It uses Spring data. And on my Spring repository, I have an annotation which exposes my repository as a REST endpoint as well. So I can access, as a result, I can access different parts of my data model, the actual data in that model, as a RESTful invocation. So I can say, as you can see here, I can grab items, and this is actually a shopping list, a grocery list. So I can see different pieces of food that I'm buying and the cost. So it's just a regular grocery list: bread, milk, etc. I can, because this is just JSON, I can add a 1 at the end, and I can grab just my first item on this list. Now, one of the similar to the previous hack, the way we're going to attack this is going to be via something called SPEL, the Spring Expression language. And this is effectively a querying language that we use. And as part of this, we are going to be, in this case, what we're going to be doing is grabbing the runtime and running an exec on that runtime. And this time we're going to cat the etc password. Okay. And then we're going to grab that and send that output straight back to us. And the item that we're going to attack this on is just our local host, passing it a RESTful endpoint that we are seeing. Okay, this is all just because this is the vulnerability occurs between this range that that I'm running on right now. So if I was to run this locally, there we have the etc password of, in fact, my local machine, because this is something which I am running locally on my environment. So it's not just struts. There are other frameworks and things like that can be susceptible. Struts is one that is more susceptible than others for remote code execution. As we've seen in the past, there are many different vulnerabilities that have been found on that environment. Okay, so my next attacks are going to be made in this application. Now, this is a Node application, but really the language that you're using doesn't really matter too much, because vulnerabilities tend to there are some vulnerabilities that are language specific, but many exist across many different ecosystems, and it's just different libraries that have that same issue. In fact, actually, before we jump, let me show you one more Java issue, which I think is an interesting one that I want to make sure I show you before we go. If I click on uploaded files or my files, we can see this is a public folder, and the idea of uploading files is to upload specifically files that in a zip file that I can import a large batch of to-dos. So if I had a list of to-dos, I can import them and they would exist here in my to-do list. However, when we do zip file extraction, there is the potential for a directory traversal to exist in that, whereby by adding ... etc., we can extract to a destination and break out of the target directory we want to unzip a file in. It's actually something which is legal for zip files and archives, but not necessarily something we want to happen in our file. So in this case, I'm going to choose a file that I want to run, and let's go to exploits zip/slip.zip. I'll open that file, and before I upload it, let me show you what that looks like. So let me come back out to here, and let me jar -tvf zip/slip.zip. Clear the screen so you can see that. So what we have here is a good.txt that can provide, a number of, useful to-dos. But I also have a file that contains some directory traversal, and it drops something in my JDK. How do we know this exists, this JDK location? Well, if I was to look at my path, we can see exactly where the JDK exists in my location. So that gives us the information that we need. So if I was to take a look at what exists, what we're trying to overwrite here, it's a native to ASCII file, which just echoes back some text saying, gotcha. Now, how is this used currently today? Let me right click on this and open a new to-do. There we go. And in this new to-do, what I'm going to do is I'm going to add, let me create a pi character just so we can see. Here's a pi character. If I was to look at this this mathematical pi character, just add any date and click create, we can see the title performs a native to ASCII conversion and encodes this in a regular ASCII encoding. So this is how the native to ASCII file, the native to ASCII script is used. So if this upload is successful, we click on it, we can see files that now exist in the public folder include good.txt, but it doesn't include this native to ASCII. So one of two things has happened. Either this has been recognized as a directory traversal and blocked, and it's blocked silently, or this has extracted and it's overwritten the native to ASCII file so that when it gets run again on the title of my next to-do, we will see this echoed from that script. And as a result, our title will be this gotcha. So let me jump back and let's create another to-do to see exactly what happens. Doesn't really matter what I type in this title. Let's buy some milk. And if I hit create, all of a sudden we have overwritten by using directory traversal, we've overwritten an existing file, which then gets run by this Tomcat server as well. And that has now changed the way this JDK will work for all of our users who are using this application. Equally, I could potentially change a file which maybe will be run by other processes, maybe a root process or something like that, if I wasn't running as root. It depends what we change on the environment. Now, this is actually, let me show you what this, if I was to go to zip slip sneak, let me show you what this actually is. This is, let me find the Java version. So here it is. So here is the Java version. I'll show you this. So let me bring this up a little bit so you can see it a bit easier. So what we do is, and one of the big problems here is because there is no consistent way or no default way of doing zip extraction in the JDK, we tend to use libraries. And in this case, I'm using ZTZip, which is a well-used zero turnaround library to extract that for us. Now, here what we do is, this is the pure Java way of doing this, and this is a similar way that ZTZip did this. Now, what we do is we grab an enumeration of zip entries, and we say, while there are more files in this list of zip entries, what we do is we go through each one and we create a new file, and that file is the destination directory where we want to store this as a target directory, where we want to extract this to, as well as the name of each entry in that zip file. So go one by one through every zip file entry, grab the name and append it to my destination directory. And then what we do is we effectively do a copy from the element, the file here, the content there, directly writing it to this new location. Now, if this destination directory gets appended to this name without sanitization, and this contains ... slashes, we will effectively have a destination directory followed by ... slash, ... slash, and then the path. Now, this will normalize and it will reduce itself down to the minimum required, which can take it outside and store this file outside of the destination directory. This isn't a bug. This is as designed by the zip and archive standard. This is something that is a known thing. However, when we use it in Java, we are always good at thinking everyone's going to be using everything the right way. We don't think about it in a malicious way, and we don't expect people to maybe want to store things outside of the destination directory. So the fix for this, if I was to go down a little bit, the fix for this is to, when we, let me scroll this slightly. Oh, this is annoying. When we create our destination file, we first of all perform this concatenation. So we say destination directory and the new file name. But then what we say is we get the canonical destination. So this flattens the full path of this destination file. In other words, we take out the ... slashes, we work out what directory that goes up to, and then we show you that actual target directory that it wants to send this file to. And then what we say is, if that canonical destination file starts with our actual where we want it to be, if it starts with that, then we know it's going to exist within that directory structure. And as a result, there is no directory traversal. It is more something that sits in that directory, in our target directory or lower. Otherwise, we can throw an exception to say that the entry exists outside of the target directory and choose to do what we want to do with it. But we catch that example. Okay, this is something that we call zip slip. And if you want more information, you're more than welcome to, I'll send you a link to that in the chat. You're more than welcome to go to that. And by me sending that, you'll also see how out of sync we are from Zoom to YouTube. So for probably a fair amount of time, you'll be wondering why I just posted that in the chat. Okay, let's do some more hacking. And now I want to go to this Goof to do application. And in this Goof to do application, it is a node application, very similar. I can say buy milk. Oops, I can spell it wrong as well. Buy milk. I can do other things. I maybe will say, let's buy something important, a mask. Let's maybe do something important, maybe some beer. You know, we can do things like this whereby we can use Markdown and other things. I can also show you an about page where this is being served here from the public directory. And we can see some text some static text being served. Okay, so next thing I want to do is I'm going to scan this to understand where known vulnerabilities exist. This is an application that we ran, that we built, but it contains known libraries and known vulnerabilities in those libraries. So I'm going to go ahead, and everything I show you here, by the way, at Snyk is entirely free. You can use this for free as much as you want. So I'm going to jump to my integrations, and this application that exists here lives in GitHub. So I go and click on my GitHub, and I choose an application that I want to scan. So I click add selected repositories, and this is now scanning my my application. I can click on view log, and it will find a number of different pieces to my application, including in this case a package JSON, or it could find a POM XML, or it could find a Gradle build file. Exactly the same kind of thing. Now, let's focus on the package JSON, because this is more going to be around SCA, but SCA is about securing your dependencies, whereas SAST is static analysis of your actual code. So this is more this Snyk code. So I'm going to go ahead here and click on view project, and I want to show you on the dependencies, the dependency graphs that you'll no doubt see in your applications as well. And this is where our application contains direct dependencies as well as transitive dependencies. And we can see vulnerabilities in any of these, in directs, in transitives, and so forth. And it's important that we recognize where they exist, as well as what we are indeed pulling into our application. Many times we pull one library, and that might pull in many tens of libraries. We don't know unless we actually see what going down and building our bill of materials, what we're pulling into our application. So what's important now is to see the issues. And I'm going to first show something called a directory traversal. Now, a directory traversal in this case is I mentioned earlier about directory traversal being important in that previous hack, but a directory traversal typically is when an application or a server will give you access to a directory or a directory structure, and you try and break out of that directory to an area that you shouldn't have permissions and you shouldn't have access to. So this vulnerability is a read-only vulnerability, and as a result, it's considered a medium severity. The severity of a vulnerability is based on the CVSS score, and the CVSS score, this is Common Vulnerability Scoring System. It's calculated based on a number of attributes of the vulnerability. So is the attack complexity high or low? Is the scope changed or unchanged? In other words, if I hack this application, can I actually make changes on the system I have hacked, or can I not make changes? Is it unchanged? And in this case, it's unchanged because this is a read-only attack. It is an attack that I can read from, but not actually make changes onto that system. So it has a CVSS score of 5.3. This is usually out of 10. And we also have a priority score. This is a Snyk score that will tell you what risk this vulnerability has in your application based on things like whether the vulnerability is reachable, and we have that available for Java right now. The CVSS score, whether there's a fix available, whether there's an exploit available. And in this case, there is a published exploit that demonstrates how you can do that. Now, this is fixed in version this is introduced in our application through a version 0.24 here. It is fixed in a very close version 0.25, minor change for this library. So I could go ahead and click on fix this vulnerability. And what this is going to do is open a fix pull request against GitHub and say, I want this to perform the minimum update needed to consume a library at the version that contains the fix. So moving from 0.24 to 0.25. Okay, but I'm not going to commit this. I want to actually go ahead and attack this this application. So have a think about how you would go about attacking this application. I would usually make this nice and interactive, but I'm not sure with the delay we're going to have too much joy with the weights of between my questions and your responses. But feel free to use the YouTube chat, and I'll definitely see that. And for those comments in English, I will 100% see them and understand them. Unfortunately, I would love to speak Japanese, but unfortunately, I don't. So so feel free to make some suggestions and have some thoughts around this. And I'll maybe think out loud about what I would do as an attacker. So if we want to perform a directory traversal, I would think as an attacker, how would I look at trying to perform this attack? Well, try and think of my inputs. Well, I have an input here, an input box. This maybe is a place that could have access to a file system. It's more likely to have access to a database, NoSQL database maybe. Perhaps I can do something here. I can make some updates here, but there's nothing necessarily that I might be able to do here. Maybe some cross-site scripting or something, but I don't think this is going to be backed by a directory structure. So this looks good in terms of being able to choose a file or do something here. But I can tell you now, this isn't the vulnerability. This is a different vulnerability that this application chooses. Where I'm actually going to go is to the about box, because the about box, if I was to copy this and go over to a terminal, if I was to curl this, you will see that this is the HTML that is being sent across, but this is being served from a public directory. So we are accessing a directory here. We know that. This is an ST library, which in the Node ecosystem is used to serve static content. So there's a good chance that this is being served by the ST library. So what could I do here? Have a think about what you might do as an attacker here to try and perform a directory traversal. And it's good to think about this as an attacker, because as developers, we all too often think about what we need to do to get the golden path, how do I get this working, rather than focus more on the areas that could potentially break. So here, what I might try to do is, well, what we want to do is we want to traverse the directory. So I could try, why don't I maybe just try and access the public directory? Now, this looks good. As an attacker, I love this. I am being served up content that perhaps I shouldn't be allowed to see. Now, yes, we are in the public directory, but that doesn't mean I, as a user, should be able to see all of what is in that public directory. I should only need the information, the data, the files that I need to service my request. I don't need to know about the robots.txt, about the images, about the JavaScript, etc. I should just care about this, about HTML, and see it being served to me. So while this is a public directory, it could be considered a vulnerability to show this much data when I don't need to see it. So in order to perform a directory traversal, well, I could go one level back, but of course we need to think that this is an endpoint. This localhost 3001 is an endpoint that I would then obviously hit the home page, and this is the home page, right? So I don't want to do that. What I want to do is a ... So I break out of the public directory. So this is trying to still go through the ST library because we're still trying to serve something from the public directory. But I'm going to perform a ... to break out of the public directory and try and view the a listing, a directory listing in a private directory. So I run this, fingers crossed. Let's see what we're going to get. You may recognize this as the previous example where I'm actually at the home page. So you can see buy milk, buy beer, here's my goof to do. This is the home page. And it's the home page because ST is a real world library that recognizes this ... It recognizes this is trying to perform a directory traversal. And so it sends me to a safe page. In this case, the home page. It recognizes I'm trying to do something malicious and stops me doing it. So have a think about what I might do in order to get around the sanitization, the input validation, the checking that the ST library is performing on this text that I'm sending. What would you think about as how we can maybe represent the ... in a way that the ST library doesn't sanitize? And the answer here, which is a good answer across many different exploits or hacks, as you'll see, is around encoding. And what the encoding we're going to do is URL encoding. So an encoding might be, some of you maybe have seen %20 as an encoding for a space on a URL. In this case, the encoding for a dot is a %2e. So this is actually the text for %2e for ... It's doing exactly the same thing and will work if the ST library is checking explicitly for a dot character rather than the encoded version, or it's not doing a normalization on this string to decode this URL encoding back to a dot before doing its checking. So I execute this and we have some success. So we can see we are in the public directory. There is the public directory in this listing. We have performed the directory traversal. And by the way, this is a real world library that was used on thousands of websites that had this exploit. And I'm sure is still used today, an exploitable version for some websites. So this is, you know, a vulnerability which is many years old, but I'm sure it still exists. It's just the way that we as developers, we as people who are running applications tend not to upgrade or not be sufficiently aware, have that visibility for where these vulnerabilities sometimes live. So now my next question to you, and have a think about this, is what would you do now? Think about it as an attacker. What would you do to this system? What would you do to learn? And learning is a very important part of hacking and attacking. When we think about Equifax, the first hack that I showed you earlier, that hack occurred around between 1 to 2 months before the actual breach of data occurred. So hackers and attackers were in the Equifax systems for almost 2 months. I think it was around 6 weeks before the attack happened. They were learning, they were finding new ways of getting in, new vulnerabilities. They were finding how to increase their permissions, where the data was, how they can access that data, understanding about the architecture of the systems, learning more about it before performing that hack. So what can we learn about this system? Well, let's see. We have some app.js. Maybe I can take a look at the app.js. Yes, we can see this. We can see secrets hard-coded into our code. At this stage, I can curl source code. Of course, in Java, I can reverse engineer it and take a look at the source code from there. But we can start looking through source code and finding other ways in. I can also see in this case what our other dependencies are, what I am requiring. Exactly the same. What am I importing in my Java space? Let's take a look here, see what else we can look at. Maybe I'll have a look at my Docker file. This is another interesting one. If I look at my Docker file, you can see what Docker image we're using. We can see some of the things we're running, some of the ports, what we have installed. You'll notice that there is no user, no user keyword here. Now, if there is no user keyword, I'll ask a question. I'll hopefully see some answers in about 10, 15 seconds or so. But does anyone know, if you don't have the user keyword here, which user you would run that Docker image under? So that's my question. Let's see if there's anyone who can answer that one. It's not unusual not to know it. It's fairly well known. But if you don't have the user directive, you will be running that container as root. So you will have as many permissions as you can. In this case, we are not running this user. We are not running this as a user with reduced permissions. As a result, this is running as root. So what can I do from here? Well, if I'm running as root, I should have access to the root directory, and I can do that as many times as I like. cd ... cd ... and I will ultimately find my way back to the root. If I do a cd ... I'm still in the root. So from here, well, maybe I can have a look at the etc password. Maybe I can have a look at my shadow file. And this is all of that Docker container. Now, at this point, we can start looking at the whole system pretty much, and we can start understanding configuration of the whole system and so forth. Very interesting to gather that data, perhaps find a route in with greater permissions. I can also take a look at the package.json. Now, this is very interesting, so specifically from a JavaScript point of view, but from the Java point of view, there will equally be other ways in which you can grab this data. Very often we don't deploy with our POM XML, but we can see from the files that exist there, which libraries we are using and so forth. Here we can see the libraries and the versions that we're running at. So for example, if I scroll down, I will know that I have a code injection here. I know I have a number of vulnerabilities here. This is regular expression denial of service. Lodash will have plenty of vulnerabilities. jQuery, plenty of vulnerabilities. A very interesting cross-site scripting here in Marked. I can maybe show you that one next. ST, this is the version that we are deployed at right now. Vulnerabilities here. So this is a really good way of learning and finding new vulnerabilities. So why don't MS is a vulnerable library. This is a regular expression denial of service here. This is not a vulnerable version, but I know Humanize MS does use this a vulnerable version. So why don't I go back and hack this one and see if we can do something else to this server. So I'm going to go back and show you, if I go back into my, over here into my package JSON. And I'm going to take a look at the humanize, what was it? Redos. So in here, oh, maybe I actually, maybe I updated it. I might have already. Oh no, here I think this is. We'll see if I fix this or not. This will be embarrassing if I fixed it, but we'll find a way around it. I normally try not to fix my. I normally not try not to fix my vulnerabilities here so I can actually show you the exploits. But we'll see. I don't think this is exploited, so I think we're good. Sorry, I don't think this is fixed, so I think we're good. So a regular expression denial of service. If I click down, you'll see a bunch more information about this, and this is added by our security team. This is all available. If you wanted to, this is all open source. So if you wanted to go sneak.io/vuln, you'll be able to see, click on Maven, for example. This is ultimately Java, and have a look for, I don't know, let's go struts or something like that, and click on the struts core. You'll be able to see all the vulnerabilities, denial of service, regular expressions, code injections, etc., as well as which versions you might want to pick based on that. So you'll be able to recognize where most of the vulnerabilities are, and in picking the correct version, you'll be able to see that. So if I click on here, and let's find more information about what a regular expression denial of service is. Well, we know what regular expressions are. In this case, what we want to do is create a denial of service, because the engine which is performing the pattern matching goes on. In fact, I would say it uses an incorrect approach, an incorrect algorithm, so that what it effectively does is it exhaustively looks for all permutations to try and find if a string is a match against the pattern. So when we look at time being spent, you'll notice obviously the more times we add something, like a C in this case, this will take longer to check all the permutations if this does not match. So let me actually take you to, let's go to a simpler example, and let's go back here, and let's just grab a I don't know, let's go A, B, and then let's have a plus here and a star. Okay, something simple like this. We have to start with an A, and then we can have any number of Bs. Okay, now the first time this matches, it will match, and it will probably match. I think star takes, I'm not sure what takes precedence. I think star takes precedence. So what it will probably do is it will match A, and then it will match lots of B plus, B plus, B plus with each of these Bs. And it will, first time it finds a way, it will stop and it will say, I found a match already, we're all good. However, if I put something that doesn't match, it'll do exactly the same to start off with. It will match A, it'll do a B plus, then another B plus, then another B plus, then another B plus, etc., until it reaches the C. And because there's no C here, what it will do, or what some algorithms will do, these algorithms are the ones that cause this issue, it'll maybe backtrack. So it will say, okay, what I'll do is I'll match up to here, find I can't match. And in this case, I'll use these last two Bs as one B plus, and all the others I will do using the star as different B pluses. Then it will try and do it in a different way, in a different way, in a different way. And it will do this every single time, failing on the C. Now, the number of steps that are required for every additional B here grows exponentially. Okay, so I don't need to add too many more Bs before the time increases and increases. Now, this is how we get this regular expression denial of service. So let me go ahead and run a couple of examples. Okay, so let's type MS2 maybe. Right, here we go. So what I'm going to do here is I'm going to echo some content. So this is going to send a to-do, and this to-do is going to buy milk in, and it's going to print the character 5, and it's going to do it 60 times. So there'll be 55555 in that many minutes. It's going to send that to my local host. I execute that, Here is the string that we create, buy milk in that many minutes. If I go back to my runtime and refresh, you will see there it is, buy milk in that many minutes. Okay, that seemed to work, or at least whatever that says, plus 56 to 3 days. Wonderful. Let's try that again, and let's grow this more and more and more. So I maybe say, instead of 60, let's do 6,000. I run that, and now we have plenty more 5s, and it still goes very, very quickly. However, let's try 60,000. Now, the number of steps now is huge, and it works very, very quickly. In fact, it takes the same time. And the reason is because it matches first time. So what I need to do is cause a mismatch at the end so that my algorithm, the library that we're using, will backtrack lots and lots and lots over these 5s. And that will take an amount of time. So to cause something that doesn't match, I'll maybe change this to minute A. So it can't match minutes. And it will now start backtracking over those various 5s. I run that, and I'm really glad to say that I didn't fix it. So if I type hello here, hopefully you hear my keyboard there, hit it about 7 or 8 times, nothing happens because we're going over that backtracking, and we've caused a denial of service until such time around now. There we go. That timing was pretty good. Around now, when either the request times out, or we have gone through all of the permutations, all of the ways in which we can represent, or combinations rather, where we can represent that string with the regular expression. And we carry on then servicing other requests in the queue all these times I hit return. So this is a regular expression denial of service. So the denial of service is based on computation. This is cycles on the CPU that is trying to find these combinations. So we are denying service through computational rather than other DOS styles, which is maybe number of requests, or it could be using up disk space or memory, those kind of things. So this is a regular expression denial of service. Okay, let's now jump to a couple of other attacks before we start thinking about how we as developers want to defend against this. The next attack I want to show you is going to be a cross-site scripting attack. And the cross-site scripting attack, where am I? I want to go back to my package.json. And let's find a cross-site scripting attack, this time in the marked library. And in marked, I think there are a few cross-site scripting attacks, actually. Yes, you can see quite a number of cross-site scripting attacks and denial of services. Now, in the marked cross-site scripting attack, this is a very interesting vulnerability that exists between the package, the library, and the browser. So there's a clue as to where we might be able to attack this from. Now, let's go to the back to the application. Now, a cross-site scripting attack is where I try and embed a script into this page such that other users, when they visit the page, will run this script unintentionally, and it can perform some malicious intent. Perhaps it will maybe grab some keystrokes and send it to me. Maybe it will grab the session cookie and send it to me. And I, as a malicious user, can then go in and impersonate you by using the same session ID. So what would I think as an attacker? Have a think yourself as to what you might do to try and attack this website. Well, I want to do some form of input. I want to have something that represents a script on this page. I want to embed a script on this page. So some of you might be thinking, well, what I want to do is I'll use this input box, and given what I type in here is being displayed on the page, I wonder if it will recognize HTML tags. So let's put a couple of HTML tags in here. And the HTML tags that we're going to run is a script. And this script will just be an alert passing in 1. Okay, so we're going to run this script. Now, whether this is sanitized or not, again here, the bug is in Markdown, is in the marked library. Marked is what allows us to do certain things like this bold, for example. So is this going through Markdown? Well, let's take a look. If I run this, you'll see what I was hoping for is that when this displays, it doesn't recognize these as special characters, and it just tries to display brackets. It tries to display HTML, which will, in fact, embed the HTML into the page. But in this case, it recognizes them as special characters, and it is displaying them as special characters. So not great for me. Let me actually go back and show you. If I was to go back to that other attack that I was doing, where I was doing directory traversal, let's have a look at the app.js. And now I'm actually showing you why that other hack didn't work through this hack. This hack shows we are enabling sanitization on the marked library. So marked is set not to sanitize by default. So we have to say, I want this sanitization to be true. Okay. This is to make it more realistic, to make it a more realistic example. So, okay. So we know sanitization is happening. Okay. What else can I do? Well, when we think about this from a markdown point of view, what markdown structures can I put here that I could equally add some JavaScript on? There's a question that we as an attacker will think. We know there is a vulnerability in the markdown library. What markdown can I do that can add some scripting? Well, perhaps what I could do is something like this, a link. But instead of a link, so if I was to go sneak, for example, add an S there. If I was to add that, we can add a link. Okay, that's great, but this is using the HTTP protocol. One thing I could do is add a bad link, but instead of using HTTP, do some JavaScript. And here we can add an alert of 1. Okay, so this is providing me a markdown way of adding some malicious JavaScript, or some JavaScript at least. If I was to run this, let's see if this works. It doesn't, okay? And it doesn't work. If I open this up a little bit to see what's in there, it's showing me it, but it's not displaying it as a link, because it recognizes again that I'm trying to run some JavaScript. This is a good sanitization on marked, and it doesn't like there being a colon here, and it doesn't like these brackets being part of this with the colon. Doesn't like the JavaScript colon straight after. So, okay. Now we as an attacker will think, well, how can I get around this? How can I get around the sanitization? Well, if we think it's something to do with this, we do what we always do. We encode, and we encode, in this case, through HTML encoding. So what is the HTML encoding of that? Well, the colon is ampersand pound 58 semicolon. So the brackets are ampersand pound 40 and ampersand pound 41, right? So we are sending the same effective thing, but encoding areas that we think that this library might not like. So it doesn't like the colon, fine, we'll encode it. It doesn't like the bracket, fine, we'll encode it. If it doesn't do any normalization, or if it's not checking for encoded versions, encoded strings, then we might have success here. So I click enter and have a look at what we've actually got. Well, it didn't work again. It's actually turned them back into colons and back into brackets. So that didn't work. Okay, it didn't work because it's recognizing that this is still a malicious attempt. Now, I mentioned earlier that this is an issue that exists between marked and the browser. This is an interesting one. I really like this vulnerability, because for when we think about it, when a browser tries to help us, if I was to write some HTML and I write a div or an anchor, what might happen is my browser will say, oh, you didn't add a closing anchor or a closing div, I'll do it for you. And it helps us when we give it poorly, badly formed HTML, it helps us so that it can display it in a way that it thinks we genuinely want to see it. However, as a malicious attacker, what I might do is say, well, yes, I know the marked library is looking for this exact encoding for a colon, but what if I was to provide a version of this text, this encoding, that marked doesn't see as a colon or a special character, but the browser will actually recognize it, even though it's not quite, it will recognize it as close enough and will change it into that character for me. In the same way, the browser adds a closing anchor or a closing div tag. So I'll do that. And I'll do that by only sending this information. And why don't we add this afterwards? So my application, my marks library will recognize this as a JavaScript command. The 4 letters before, 4 characters before, is not a colon because it doesn't have a semicolon afterwards. So this is not a special character. It will therefore pass the sanitization. And by the time it gets to the browser will look at this and say, it's not a colon, but it's so close. That's what I think you're trying to say. And I will turn this into a colon for you. So it passes the sanitization. It gets to the browser turns it into something more malicious than it actually is. And as a result, we get this link. And if I click on this link, you might be able to see. It's very hard for me to see, so I doubt you'll be able to see it on the YouTube stream. But you might be able to see on the bottom right, you'll see JavaScript colon this semicolon alert brackets 1. So this, if I click, now turns into my alert. I've achieved my cross-site scripting. And as a result, what I've done is any user that now can see this page with this link, they will then automatically see that. Now, what can they do? Well, I can maybe grab a document. I can, instead of just doing an alert, I can maybe grab a document, grab the session data, and then start impersonating all those users. Maybe what I can do is a good way of grabbing that data and sending that data is to set up a malicious server. And for when people click on this bad link, it actually sends a request out to that, or it tries to get something from that malicious server, maybe an image or something like that. But the name of that image is actually the maybe a base 64 encoded session ID. Then I, in my server, my malicious server, will see request after request of resources that aren't there because it's a base 64 encoded session ID. I just decode those and I have a ton of session IDs that I can now use. So this is the kind of way which people might try and maliciously get some of your data. Okay. We have about 35 minutes left. If anyone has any questions, feel free to ask them. I'm happy to take them as we go. Feel free to drop them in the Zoom chat for the JUG leaders, and I'm happy to answer them there as well. Okay, let's now go on to how we as developers think about fixing these kind of things. Many of you will have heard of things like shift security left. Those kind of buzzwords like DevSecOps, those kind of things. And what they're realistically trying to do is encourage developers to work with security teams, to encourage developers to be empowered through security teams in order to more vigorously look at the code they write, the packages, libraries they pull in, the container images that they choose to use, the configuration they choose to write, and to own the security implications and the security testing that needs to happen. And we're not talking serious, complex tests that you need to construct, etc. What we're thinking more about is, are there known vulnerabilities here? Am I writing code structures and missing key things like allowing SQL injection or allowing code injection and so forth? These are the kind of things that we can pick up very easily and fix very, very easily. So as a user, what might I do? So do I have IntelliJ up and running? Let's grab IntelliJ. I think most people will probably be using an IntelliJ or something like that. And as soon as this kicks off, there we go. Okay, so we're running Java. We're loading the Java Goof project, and what this is going to do is give me, in this case, a list of the Maven files that I might want to test. Let's grab this struts one. This is a free Sneak plugin that allows us to view all of the issues that exist that are coming in through my POM XML. So my POM XML creates me my dependency graph. These are the issues that are coming in from that. From here, I can choose. Well, in fact, I wonder if I have. I'm not sure if I'm using. I don't think I was using the zip slip. The version that the vulnerability that I exploited earlier when I updated the native to ASCII file. I can't see it here. Okay, so maybe it's already fixed in here. But ultimately, you can kind of like take a look at this, and I can see exactly where I'm pulling in the issues from, what version I'm using, and what version I need to upgrade to in order to fix my issue. So in this case, fixing Apache Struts core from version 2.3.20 up to version 2.3.34. This is the update I need to make in order to eliminate this denial of service from my application. This is a great way of identifying issues very, very quickly. Another really good way is let's go to VS Code, and I'll show you a really neat integration that we have there. Again, all entirely free. What you can do in VS Code is, if I go to my app.js, this works for JavaScript and TypeScript, by the way. If I go to my app.js, as I type, you will see vulnerabilities being appended to the line. So this is a great way of getting that fast feedback. And I can see, okay, in ST, it's got 4 vulnerabilities. I can click on the balloon. I can click on fix vulnerabilities, and it will tell me what my remediation is and what my vulnerabilities are. So in this case, I have 2 vulnerabilities that exist in direct dependencies, 2 vulnerabilities that exist in my indirect dependencies, and what version I need to fix that. So this is very typical for known vulnerabilities in third-party libraries. The upgrades are simple in terms of fixing them is pushing them up to a newer version. The trick is recognizing how that might impact my code. So if I upgrade to a different struts version, a different Spring version, or a different ST version in this case, does my code in 2 ways still behave well with that? Does it, first of all, compile against the new API? But secondly, is the behavior the same in that new API? So it's important to check your change logs. It's important to check your, use your tests. Make sure that, I'm sure you all have wonderful test suites. Make sure you run everything through those amazing test suites to make sure you're not seeing changes in behavior as well. Exactly the same that you would do when upgrading any dependency. There's no difference, that the fact that it's a security issue that forces this upgrade rather than a functional issue. You do exactly the same things, exactly the same checks. Typically, for example, for this directory traversal that we showed earlier, this is this directory traversal I've just opened up here. This one just needs to jump you up to 0 to 5. Okay, so 0 to 5 will provide the version will provide the fix for you. So in that case, going from 0.24 to 0.25, you wouldn't expect there to be a major compatibility issue. But this is a great way in our IDEs to first of all be identified, be notified of where issues exist. Okay, another way, if you're loving the command line, another way that you could test is using a command line interface. And by the way, there are of course other tools that you can use to do this. I'm just using Sneak here. One, because it's what I'm doing here is free. Secondly, because I work at Sneak, of course. But I can run a test tool that will do exactly the same. It'll analyze and query the Sneak database and provide me with the same responses as to what issues exist that sometimes aren't patchable or aren't upgradable, because we depend on two things. First of all, an upgrade path being available, an upgrade being existing from the maintainer of that package. And secondly, that package will exist in a dependency graph in your application. And you don't just require an updated version of your package to be public from the maintainer. You also require anything that depends on it to consume that updated version. So if there's a fixed version, you want your direct dependency to consume that fixed version rather than an older version that contains that fix. So you need both of them to be available. Sometimes where they're not, Sneak will provide patches, mostly for NPM examples there. But in this case, you can see how these upgrades, in fact, this is the one that we just saw in VS Code, upgrading from version 0.24 to 1.22 will fix all 4 of these vulnerabilities. And this package view of how to fix can sometimes be easier than individual vulnerabilities, because sometimes if we are fixing a package, if I need to go to 0.25, yes, there's probably going to be very little impact on me. But if I am changing this package, maybe I can jump to an even higher version, and for that to actually eliminate many more vulnerabilities. So depending on how flexible you are at upgrading your application and what systems you have in place to support you doing that, this can be a very good approach to fixing vulnerabilities. Another way you might want to do this is by always staying on latest. This is a path which some people choose for newer applications, for legacy applications and older applications that you don't have the time to necessarily invest in the maintenance. This may not be an option. So you can choose which way you want to do these kind of things. Sneak will offer both. You obviously have other things like Dependabot and other good tools that will do these similar things for you as well. So this is whether you want to do it in IDE or CLI. These are some good options as to how you can very early find that the issues, learn about what the issues are, and then fix them. The one thing about doing these kind of things is it's very hard to make sure everyone does them. It's very hard to make sure. Sorry, let me grab another window. It's very hard to make sure that that everyone tests and that every single piece of code that goes into GitHub, GitLab, Bitbucket, wherever, has been fully tested before a pull request gets sent. Which is why one of the really nice things, if I was to grab a pull request, just a generic pull request, which we've created here, one of the nice things that we do is for every pull request that is created, we run tests against. In fact, this is. Let's go to a slightly different repository. Let's go to Goof Kubernetes so we can see the actual pull request that I just created. ST. I think it was this one, was it? No, maybe not. Oh, maybe I did it in a different. Maybe I did it in a different repo. But every one of these pull requests will automatically test to see if the pull request itself affects your security posture. So when you create a pull request, the tests check if you are including new licenses that you didn't include, or changed licenses that go against your policy, your organization policy, or your open source policy, or if the pull request makes changes to the dependency graph that introduce new vulnerabilities that weren't being introduced before. And if neither of those things occur, then you will see all tests pass and you can go ahead and merge. If one of these tests fails, you can choose what you want to do. First of all, you might say, I only want to fail on a high sev vulnerability. You might say that whatever happens, if anything fails, don't allow a user to merge. Okay, so you can start controlling and policing the behavior of your application, your repository, based on the changes that are going to be made. And this is very, very important to make sure that what we do here is not regressing, not getting any worse. There are always two ways of changing your security. One is to make sure that you're not getting worse. The other one is to make sure that your backlog drops over time. And the first thing we always suggest that is very important is for actively developed projects, make sure you are never getting worse first. So plug the gaps, plug the holes, and then try and reduce the number of vulnerabilities in your backlog. So this is the first place which we say is a really strong way of policing the code that goes in. You can, of course, introduce Sneak in other places, as with other tools, whether that's during build in Maven, Gradle, something like that. You can introduce it in your Jenkins build and potentially block builds if you wanted to. Or you can take a look at it from if I was to go to slightly older date, you will see that this, while other pull requests have Sneak here, I'm going to click on this Sneak update. And this is an automated pull request which gets sent. So when I did that import, Sneak will now constantly test that project every single night. So this is an important way of being able to say, just because I'm not actively building and not actively going through a pipeline, can I still remain secure? Because I'm not testing, how do I get notified? Well, this will automatically test nightly, and it will say, if your vulnerabilities either couldn't be fixed before or a new vulnerability exists that that affects your project that wasn't known before, this will automatically send you a pull request with the update you need. Or you could be an email or a Slack message, or however you choose to take this information. Okay, let's now get back to hacking. Why don't we go back to hacking? Let's do a Java hack this time. And by the way, if there's any, is there any questions on the YouTube chat or on the Zoom? Feel free to drop them into the, I'm looking at the Zoom chat. So if there's any questions or you need to interrupt, feel free to just drop it into the Zoom chat, and I'm happy to take those as we go.
Okay, here's a question from audience.
Sure.
And what was the most elaborate or complicated real-world vulnerability or attack or you've ever seen?
Yeah, really good question. Really good question. I think largely the attacks. I mean, I would say the attacks, the actual exploits are all fairly standard. There's nothing necessarily too crazy about the way people actually do those hacks. They're actually very similar. And it is very, very rare that one hack will actually perform a breach. As with the exploit that I showed with the Equifax breach there, there was many hacks that were required to actually get you to that stage. I'll give you one story, actually, a personal story, which I always find quite funny. We have the most commonly used airways probably in the UK for commercial travel. I would say for company travel, I would say is probably British Airways. And British Airways had a hack on their website, which embedded some JavaScript on their website. And I think it did key tracking on certain pages. And one of those pages was when this happened probably 18 months, maybe. Oh, no, it must have been longer, obviously, with what's been happening recently. So it's probably maybe 2.5 years ago. And we were a fairly small company back then. And my boss said to me, Simon, I know you use British Airways and I know you travel quite a lot. Have you used this website? Have you booked anything with British Airways between these 2 times? And I said, yes, absolutely. I booked about 3 flights in those 2 days. And he said, oh, in that case, you probably want to change your credit card because all those numbers have been completely tracked and sent off to some malicious server. And I had to admit to him, I said, Guy, I actually used your credit card in booking those flights. So it was a nice way to kind of tell him, Guy, you have to change your credit card because I've made those changes myself. One other really interesting exploit or attack, malicious attack that we saw recently was something called Sourmint. Sourmint is a really Sourmint, yeah. Hang on, let me. Sourmint. So Sourmint, this was one that we worked with a number of groups, and this it was basically ad fraud, but also caused a number of data leaks. And I've done a number of videos on this as well. But some of the most interesting areas here is that this is one where a company, what they were doing was, it was a Chinese company that they were an ad network, and they provided an ad network SDK. And what they did was, when a banner or something like that was clicked, what would typically happen is, you would get attribution. The app would get attribution based on that click coming through that application. However, what this ad would do is the SDK would intercept the fact that the click has been made, and it would actually send a second click. Okay, so it goes through over to the server, sends a second click across, and the attribution actually occurs for a different person. And this was really interesting because what effectively happened was we worked with a number of companies that actually saw their ad money drop significantly. And as soon as this was launched and this was made available, within 24 hours, the month that they saw of a reduced ad money coming in went back up to the usual levels that they expected. So it was really clear that this was happening. But I think for some numbers, there's loads of data in here, so you feel free to kind of go here. But I think the numbers there were 1,200 apps, which represented 300 million downloads per month. So this was like a really significant way of doing this. Another thing which we proved was that it starts grabbing more sensitive information from you, data that you shouldn't, even when you're not using that application. So there's some really intricate areas of here, which is very interesting. So I definitely suggest taking a look at Sourmint, which is a very intricate and elaborate malicious attack. There are also some other. I'll give you another one which happened in the NPM ecosystem recently, which was. It was called Event Stream. Many of you will have likely heard of this Event Stream, Flat Map, and things like this. And what happened was the Event Stream library used another library called Flat Map. And Flat Map at the time was it was owned by this malicious user who provided some non-malicious content. But the way in which Event Stream consumed that, it provided a range. And this is one of the issues. This is one of the differences kind of like between NPM or package JSON files and POM XMLs. POM XMLs are very much more wanting to use a specific version of a dependency, whereas in NPM, it's much more common to say, give me the latest version of whatever library. And if I was to build that in 2 months' time, my application would look different because I'm using a more up-to-date version. However, what happened was the malicious maintainer of Flatmap upgraded their version with malicious code. And that malicious code, I believe it did something like started attacking. I think they had a very specific attack target, but if it was used by a certain application or a certain vendor, it would start trying to take money from a cryptocurrency wallet or something along those lines. Very, very interesting supply chain attack and how dangerous it can be to not understand the libraries that you're using and how reliable those libraries can be. So there's a few examples there. Any other questions?
Okay, not for now, but yeah,
Okay.
I want to translate your answer to Japanese.
Okay, excellent. Thank you.
Okay. 聞いてる方でももしかしたらもう分かったかもしれないですけど、なんか3つぐらい話がありまして、1つ目は、サイモンさん自身の経験で、BA、ブリティッシュエアで飛行機を予約したら、上司からクレカ情報抜かれたから変えた方がいいよっていう話があって、慌てて変えたっていうエピソードと、で、2つ目がサワーミントアタックっていうもので、ちょっと私もちゃんと全部を理解したわけではないんですけど、広告、iOS のアプリの広告ライブラリに何か脆弱性があって、で、それが、そのアドネットワークに入ってないところにこう送られてしまうっていう脆弱性があった。で、そのことよりも、それがアプリが1200ぐらいのアプリで使われていて、月間3億ぐらいダウンロードされていたっていう、その圧倒的な数、それぐらい広まるような脆弱性が、あったっていう話と。で、3つ目が、多分フラットアップだったかな。なんか、ライブラリ、よく使われているライブラリが、脆弱性を含んだコードでアップデートされてしまって、アップデートすることで脆弱性が埋め込まれるようなことが、実際あったっていう話がありました。っていうような、そのあたりの話ですね。3つ目なんかは、たまに、やっぱ聞く話ですよね。特にフロントエンドとか、ノード JS 系とかで、たまに聞くようなお話かなとも思うんですが、オープンソースのライブラリ一般ではそういうようなことが起こりうるので、そういうところは注意しましょうっていう話ですね。Okay, thank you very much. That was interesting techniques and interesting episode. I was so impressed. Yeah, I thought I knew a little much about security and vulnerabilities, but seeing the techniques like the one you showed this time, I felt uneasy and I lost my confidence.
It's definitely something you don't want to. It's one of those things that it's easy to lose your confidence, but there are easy ways. There are easy ways in which you can definitely make you and your development teams better. Visibility is one really important thing to have in your application, and then taking small steps to improve over time. It's not something we can change very, very quickly and become excellent at it, but it's definitely worth making changes, understanding where we can grow and how we can improve over time.
I see. Thank you. So thank you very much this time. Yeah, me and my people get interested. Thank you very much. Oh.
Thank you.
Absolute pleasure.
マヤさん、なんかアナウンスとかありますか？
はい、JJUG からのお知らせはですね、まず1つ目、5月の23日にですね、JJUG CCC 今年もやります。バーチャルですけれども、ありますので、ぜひご参加ください。きっと URL については誰か JJUG の数の人がこれから出してくれると思いますので、もう一回ツイートをこれを見ながら、流れてくると思いますので、ぜひご登録をお願いいたします。あと、きのこさんの方からもう一つアナウンスがありますので、お願いしてもいいですか？
はい、これ聞こえてますかね。はい、ですね、ちょっと5月のですね、今度ちょっと、おそらく6日、まあ、これは確定かな、5月の6日にですね、実はちょっとゴールデンウィーク特別企画ということで、イベント、勉強会を開催しようと今企画をしています。これがですね、スペーシャルチャットという、ビデオチャットサービスを用いて、参加者さん同士でビデオチャットで、まあ、ちょっとこう話したり雑談したり、こう、なんかできるような感じのコンテンツを今考えてますので、ご期待くださいというところで、まあ、イベントページ、そうですね、近日、準備して公開する予定ですので、もしよければ皆さんですね、ぜひぜひ、ご参加くださいませというところで、よろしくお願いします。はい、以上で。
以上ですかね。
はい。
ありがとうございます。
ありがとうございました。では、はい、今日の JJUG ナイトセミナーはこれにて終わりたいと思います。Thank you very much this time. じゃあ皆さん拍手で最後、ください。ありがとうございました。Thank you very much.
Thank you.
これでは、セッションを、ナイトセミナーこれで終わりたいと思います。もう配信の方は停止します。
ね、さようなら。
さようなら。
Okay, I closed.
では